Greetings, friends. We're going to talk about multi-step equations today. And multi-step equations are sometimes going to have variables just on one side first. And then we're going to look at some that have variables on both sides. All right, so this is what the page looks like in your notes. You may want another piece of paper so that you can write down more examples, because I'm probably going to give you more examples than what you can fit in this space. So if you're watching the recording, you might want to pause and grab yourself an additional piece of paper. So generally, the rules are that we want to simplify the expressions on each side of the equation, get the variables on the same side, then it's going to be a two-step equation. All right, so then you would just proceed as normal. You're going to get to a point that it looks familiar. So in today's lessons on IXL, which is going to start today, we're going to go J5. All right, so J5 on IXL. In J5 on IXL, there's only variables on one side, so we won't have to worry about that part of things. I'm also going to show you some problems where there's more than one way to solve the problem. And I know sometimes that makes you a little nervous because you want to just have just tell me the way, right? But sometimes there's more than one way to get to the same place, right? So first example is like what I gave you yesterday. This is an example that you would see in J5. And this is really still a two-step equation, but it follows a little different rules because the whole top, right, the x and the 2 are part of the fraction. So in a case like that, we're going to have to multiply first to get rid of the fraction. Then I'll have x plus 2 is equal to 45. And then I can subtract 2 on both sides. Did not manage my space very well. And again, remember to check. You just plug your number in. So 43 plus 2 is 45. Divided by 3 would be 15. So it does work. Okay, so I gave you examples like that yesterday because I thought, there really are just two steps, but they put that in J5, not J4. All right, so I'm getting ready to erase that, so pause if you don't have it written down yet. So another example here of what I would normally consider a multi-step equation would be, but variables only on one side. Perhaps we have 2x plus 7x plus 2 is equal to 20. So we would simplify what we can. So the 2x and the 7x, we're going to combine like terms. So that makes 9x, and then 9x plus 2 is 20. And then hopefully from yesterday, you remember how to solve a two-step equation. If not, we're going to get lots more practice today. I'm going to subtract 2 on both sides. That gives me 9x is equal to 18. And then I'll divide both sides by 9, and x is equal to 2. So that would be an example where we need to simplify that left side before we proceed on and it becomes a two-step equation. Sometimes people will go ahead and subtract the 2 first, but I feel like it's best if you combine your like terms first, because then it looks familiar to you. Then it looks like a regular two-step equation. Of course, we know it could have been written in the opposite order with the 20 on the left and the long expression on the right. You would still be trying to get the x's together and then get the x by itself, solve for x. All right, getting ready to erase again. I like that better than leaving it so cluttered. So if you're writing smaller, you may be able to get all your examples in this space. If you are writing as big as I am, you wanted that piece of paper that I mentioned at the beginning. So here's a problem I'm going to show you two ways to do. So I've got 3 times x minus 5 is equal to negative 18. I'm going to do the same problem over here, just showing you two different ways to do the problem. So I think for most of my students, our inclination is if we see parentheses, we're going to use distributive property because we know how to do distributive property. And that's fine. I can simplify this side by doing distributive property. And then notice now it's a two-step equation. So then I would add 15. Be careful with those signs or grab your calculator if you need it. So negative 18 and positive 15. Opposite signs, so that ends up being negative 3. Divide by 3. And x then is equal to negative 1. Hopefully that makes sense to you. Now I'm going to show you another way to do it. That is what they're going to show you in IXL if you miss the problem. And it's actually a little shorter. So instead of multiplying it out, we could just divide by this 3 to get the parentheses by themselves. Now that only works if that number if it's just a number on the other side, and it only like there can't be like other stuff outside the parentheses besides the 3. So that's part of why it's not the way I usually show it, is because there are limited number of times that we can use this method. When we can, it's pretty cool because it becomes only 2 steps. So when I divide by 3, that gets rid of the 3 on the outside. That becomes negative 6. Then I just add 5. And x is equal to negative 1. So both ways we get the same answer. All right, so I usually teach people this way because the way on the right can't be used all the time. But I want it to at least show you the way on the right because, like I said, in IXL, if you miss one of those questions, that's the way they're going to show you. And I don't want you to be confused and think, but Miss Carolyn didn't say to do it that way. There's more than one way to do it. If you do it the way on the left, it's going to work. If you do it correctly, you're going to get the same answer. So I'm going to show you a problem next that you can't do both ways. All right, so the next problem I'm going to show you cannot be done both ways. So getting ready to erase again. So it looks like I should have put a whole page of blank paper in there, right? Also, I did not have a chance to update these notes from last term, and so that's why there's information about Odysseyware at the top. We aren't using that program anymore for this class, but my apologies. Sometimes there's just only so much time, and I did not have time to go through and get rid of all that. So bear with me. Also, the way that they organized the sections, they jumped into having variables on both sides right away. And so that's also why it was kind of combined here. So my next question, this is one that I could not use the shortcut. Oh, hello. I don't cut. I was not trying to do that, so let's get rid of that. I'm not sure exactly what was going on there. Apparently I hit something extra. So it may be obvious to you that you can't use the shortcut because the -2 doesn't divide into the 7. But also, there's like this extra stuff outside the parentheses besides the -2. So you cannot use the shortcut. You would want to simplify what you can on the left. So just think about the left as if it's like an expression you need to simplify, because it is. So we're going to distribute first. -2 times x, -2 times -7, so that's going to become +14. -2 does not get multiplied times the 3x, because the 3x is not inside the parentheses. He's just hanging out here, waiting his turn. So I would distribute, then I would need to combine like terms, and I know that my -2x and my 3x are like terms. So -2 and +3 give me 1x, or just x. So then x plus 14 is equal to 7. And I just kept that over here for those of you who like to put a line down your problem. Obviously the x plus 14 could be written further to the left. Now I'm going to subtract 14 on both sides. In this particular problem, it was only one step left because it's just 1x, so I won't have a division step. And then 7 take away 14 is -7. And then remember, any of the problems, you should be able to put your solution into the original equation and see if it works. So -2 times -7 minus 7 plus 3 times -7 should equal +7. Lots of 7s in there. So inside here, this would be -14. And then -2 times -14 is 28. 3 times -7 is -21. And 28 minus 21 is 7. So it works. It's true. All right, so you didn't have much space to write down all those examples, but those are some examples. If you need more examples, if you're working in J5 and J7 today, if you're working on those lessons and you're finding, wow, even after watching her video, I need more help, then you need to find a way in your schedule to try to make it during class time. I know that's not always possible, but it is class time. It's not supposed to be just independent study. So we have class from 9 to 11:45 with a 15-minute break. So Monday through Thursday. Miss Elena is available on Monday and Wednesday nights to tutor. So if you work during the day, but evenings might be a time you could come, Miss Elena is available to tutor on Monday and Wednesday nights from 5 to 8, but I have to know, like by noon that day, that you intend to come. And then I will give you the information to for her Zoom, and I will let her know to expect you. So if you say you want to see Miss Elena and we schedule a time and then you don't show up, we're not going to schedule more time with Miss Elena for you. So please, if that's a resource that you need, it is available. Or if you can make it to class. And then on Fridays, typically 11 to 1, always check in with me to be sure. but typically 11 to 1 are times on Fridays that I'm available for tutoring. All right, so I hope that the videos are helpful, but there's just no way that I can give you as many examples as I would in a 3-hour class. All right, well, have a great day. And again, reach out if you have questions. Keep in mind those tutoring times. That might be helpful. Okay, so I decided to add a little to this video. So in IXL, you're going to log in, and obviously you're not a teacher, so you're not going to see exactly what I do. But if you click recommendations, then you're going to see, Mackenzie just happens to be the top person, alphabetically in my class, but then you're going to see so many skills suggested by your teacher. Some of those you may have already done. I started trying to unrecommend if you are finished with it, but I recommend for the class. All right, so then you're going to see like, oh, these are the things that she has recommended. So these top 2 were the last ones I recommended. That's today. The solving advanced linear equations and complete the solution. So we're going to look at complete the solution. So that you kind of have an idea of what that's going to look like. So they're giving you either the steps or the process. So what they've said is divide both sides by 2. So remember, this is the one that you could distribute or divide first. So they're saying they divided both sides by 2 first. That would give us 9. And then subtract 3 from both sides. That would be 6. So they're not showing, but it's the same thing. Like we might write divide by 2, subtract 3, subtract 3. So they're walking you through the steps and you're just taking them. They're telling you on the right what to do. So you're going to have some problems at the beginning of J7 that they are going to tell you what to do, and you're just going to carry it out. So I'm going to subtract 19. Well, that's 0. 0 divided by 10 is 0. As we go, then it may, instead of asking us or telling us what to do, it's going to show us something has been done, and we're going to have to decide what to do. So far, still the same thing. So here, what did they do? From the top line to the second line. They got rid of the 3, right? And they divide it by 3. So use the drop down arrow. And what did they do? They divided both sides by 3. So you might solve the problem by doing distributive property first, but when you look at their steps, you're telling them what did they do. So then if we subtract 17 from -3, -20. So what did they do? Looks like they multiplied by 6. So then I would say multiply both sides by 6. And then subtract 6. So part of an assessment grade for you is going to be for you to tell me the steps that you did, not just tell me the final answer. So please be sure that you're paying attention to things like this, because what's written at the right will be part of what you're assessed on. All right, well, it's time for my regular class to start, so you guys have a great day. Thanks.